Welcome to today's live stream on how to prepare for a programming contest. We couldn't have a better guide than our guest, Niyaz Nigmatullin, today. Niyaz is a two-time ICPC world champion and coach at Constructor University Bremen and Neapolis University Pafos. But before we dive into the session, let's quickly glance at what we have lined up for you today and share a little announcements. This February, we are hosting an Olympiad in math and programming for young enthusiasts aged 13 to 18 called the JetBrains Academy Youth Challenge. So gather your friends and prepare to have some fun if you dare. And for those eyeing universities applications this year, here's something you shouldn't miss. We collaborate with two European universities, Constructor in Germany and Neapolis University in Cyprus. Lastly, before we move to our session, remember that participating in challenges is not just about competing. It can be a stepping stone to your dream university. If the bachelor's program at Constructor University piques your interest, don't forget to register to the Constructor Open Cup. It could be your shortcut to a world-class education in computer science. We'll have all the necessary links in the comments below for your convenience, of course. And also, we'll try to fit in a Q&A session after the talk, so don't hesitate to write them in comments section. By the way, the live stream will be recorded. And now, without further ado, let's welcome the man of the hour. Niyaz, the stage is yours.
Hi, everyone. So I hope everyone hears us. So today we will talk about programming contests, and I think the talk is mostly for the beginners, and for the experienced contestants. I hope you will find something interesting, but well, this is mostly for beginners. I will talk about a little bit what the contests are. I will talk about my experience on how it's better to prepare for them, and I will talk about how to behave during the contest so that you do your best. During the talk, you can ask questions related to what I'm talking about. In the end, you can ask any general questions if you want. I will try to read your comments, and I will try to answer the things that are related to what I'm talking about, instantly. So, what is the programming contest? So let me introduce myself. I'm Niyaz, and I was doing competitive programming for 15 years, I think. I started in high school. Sorry for that. I think my browser has crashed.
That's okay, but we can't see your slides at the moment.
Sure. I'll share them, I think. Yeah, that works.
Yep.
So I've been competing for like 15 years. I was coaching for another 9 years, and last year I started coaching my own teams, but not just in some schools or camps. And so we had some results in last competitions. So our teams advanced to world finals once, and we had some medals and regional competitions in ICPC. Yeah, that's about me. So let's get to talk what is actually a competitive programming contest. So actually, we will talk only about competitive programming today. I just want to say that there are many other competitions you can run into. Well, some hackathons, I don't know, AI bots, robot AI programming, and others. And all of them are, if you're looking to IT, if you're coming into IT, all of them are usually very useful for you. And most of them contain the same advantages do competitive programming. So if we talk about competitive programming contests, there are, so I can divide them into team contests and individual contests. And for the team contests, there are teams, and for example, the ICPC is the one, the competition for university students. It's in team of 3, and they have only 1 computer to code. Some other team contests can allow more computers to use. For individual contests, people compete by themselves. And for example, in IOI, they have, I don't know, like 3 problems in a contest most of the time. And so these problems are like the rules for the contest, they differ by how you score, because sometimes you need to solve the problem and it has to work in all test cases. Sometimes it has to, so you score depending on how many test cases you pass. And they also differ by how the solution is being tested. For example, in Hacker Cup, you should submit not your program, but you should submit the result. And at some other competitions like marathons, it also can happen that you can submit either your code or the output file. So there are a bunch of competitions. Just on the slide, I've included some of the competitions that run nowadays. There are many competitions that were before but are not today with us. So here are just some photos from the international competitions. The left is IOI, is the competition for high school students, and on the right is ICPC, is the international competition for university students. And as you see, like the ICPC, there is only 1 computer for a team of 3, and for the IOI, each student has 1 computer. Okay, so what the competitive programming is about this? It's about solving problems, and it can be several problems during the competition. And the problems, they mostly look like this, like you see on the screen. So they have some legend. Well, this problem doesn't have a legend because the problem with the legend couldn't fit into the slide. Mostly there could be some story behind all of this. So there are some specification for how input looks like, and how output should look like, and also some examples on what your program has to process input and then print. So the example on, you can run your program for these examples, and you can print. You should print what they are expecting. And so during the competition, mostly your program is not being seen by a human, but mostly it's being tested by an automatic system. And the humans just created some test cases that to run your program on. So for example, here you have a graph and you need to find shortest path. So they've created like a bunch of, 100 different test cases. For each test case, there is a graph in the input, and they run your program, and all the inputs, they meet the criteria in the input section. So there are strict constraints written in the input section. So all the tests in the system that are being tested on are under these constraints. And this testing system, they run your program one by one on the test cases one by one. And each time they just take your program's output, and they compare this output to the expected output. So there are also some limits. So for example, your program cannot use more than time more than stated. So here it's 2 seconds, and it cannot use more memory. So the resources are limited, and mostly, so the competitive programming is mostly about time limits. For most of the time, you cannot you wouldn't exceed memory limit. Time limit almost always an issue, and this is why competitive programming is not very easy. You have to come up with some algorithms that can run in a small amount of time, and new ideas can very can be very good in your effectiveness of your program to run under the time limit. Okay, so why competitive programming? You could ask if you're not very familiar with it. So competitive programming, actually, here are some ideas under it. So let me tell you what I like about competitive programming. I like to solve things and to solve some puzzles. And what I like about competitive programming is that you can implement your ideas, and the test cases given by the testing system tests your idea. So you come up with an idea, like the solution of the puzzle, then you code it, and then testing system somehow proves that your idea was correct. So you solve the puzzle, and then you have the proof, and you have a program that proves your idea was correct. Yeah, so you have to prove your solutions during the contest so that it should work or it shouldn't work. But still, this is cool that you came up with something, you code it, so you have a program that works, then you check it, and then it's cool. What I also liked is a community. So I still like to go to some competitions and meet my friends, meet new people. Probably because we all think alike, because these people that I talk to, they are smart. And I like talking to them. I like having fun. We play board games. We go to, I don't know, dinner parties and so on. What also gave me the competitive programming is my career, probably. So I entered the university because I learned I did a competition, and also the coding interviews in the company. So when I pass my interviews, they are not that hard because the algorithms I know, and I can create some algorithms. So that's it. But as I told before, competitive programming is not the only option to do that. There are other things, and probably they will get you even higher skills in some areas. And competitive programming does not help you at most of the jobs you will go to. It will not help you to get to educate better, because you still have to learn all the math, all the things, and you have to work hard. So that's not like a single key to your life, but it's somehow it helps you. Okay. So if you have a question, you can just write it in the chat. I will probably, if it is related to what I'm talking to, I will comment on that. If it's not, we will talk about it after my presentation. So what about preparing to a contest? So there are a bunch of stuff you can do to prepare for contests. So first of all, you have to learn some basics like the theory, because when you read a problem, when you try to solve a problem, you will see that something you don't know. So some ideas, some algorithms, some tricks. So the knowledge of them helps you to solve them like in any other job. So if you want to play football, or you want to, I don't know, even playing Counter-Strike, you still need to know some basics. You still need to learn some theory, and you also need to do some practice that is like where you don't need to create something new, but just do what you already know. Here it's the same thing. So you need to learn something, and you need to practice much. So that's it. So theory, practice, and of course practice makes perfect. So actually, I would do three things in competitive programming. So you need theory first, you need practice second, and you somehow need the third skill to come up with solutions. So the third skill you cannot learn, you cannot practice it. You just have to do the first two things, and then the third thing would come up at some moment. So you it's not like a human brain not working like this, so that you cannot come up with everything in this life. So sometimes you have to learn something from others, but probably at some moment of time your brain will train so that you start to create new things as well. Okay, so what to do to learn? So I will talk about here. So with the condition that you are sitting at your home, you don't have a teacher, you don't have some instructors to do that. So what can you do? You can read some articles on different algorithms. So for example, there is a CP algorithm, so that I didn't include like many of them. So you can Google them. You can find something even better what I included here. But still, you can use those that I've provided here. So I think this cpalgorithms.com. Let me just open it in my browser. I hope you see it. So it's it's bunch of different algorithms. For example, you want data structures. You go to data structure and you see here's some data structure. For example, sparse table, and here's some article on sparse table. You read it, and there is a code. You can even see how this is implemented, and you can learn on how to do different types of topics. The same as Code Forces. Code Forces, there are people. So there's a forum on Code Forces. So just if Code Forces, if you aren't familiar with it, it's a big website with different competitions and forums. And I don't know, if you want something for, I don't know, graph shortest path, you can go with Code Forces shortest path, and there are some tutorials. So people just write tutorials. Probably they are for the topic you need. Probably they're not. So for example, most probably this is not what we're looking for, or maybe what we're looking for is that. So Code Forces is also a good thing for like theory. There's also an edu section. It was some like pilot course, I think. If you just enter, I don't know, if you enter it, you will see some topics here covered, and you can learn them. So about I'll comment on the practice and theory question later. So you can read some books. You can watch some videos. I can advertise my colleague Pavel, his lecturer in Neapolis University. And he had a great course, like a 2-year course recorded in English. And it's cool. It's like algorithms and data structures course. Some of the topics are related to competitive programming, but some of them just some advanced courses that are not useful in competitive programming. Also, there can be some online courses on Coursera or other platforms. I wasn't looking for them when I did the slides, so you can just try to look for them, and probably some people already did some online courses on that. And we also started algorithmic challenges in Kotlin. I think we've created like 20 problems, and you can solve them inside the IDE. It's a like plugin with some theory and some problems. So you can try. I think the presentation will be somehow shared, so you can press on the link and find it. So there was a question. How much time should be devoted to practice and theory? I think how it works, so that you learn something a little bit, and then you try to solve some problems. So for example, if you want to get to practice, there are different topics. And if you go, for example, I don't know, here's a problem set, SCES. It's from Finnish professor from Finland, and there are some topics, and like you want to solve some problems. So for example, I don't know, shortest routes to, and you see here you need to find some shortest route, and you see that this is some graph algorithms. Probably you need to learn some graph if you don't know how to solve it. If you don't know, I know here, so what the graph algorithms would look like. You start to learn, for example, in here, graph. There should be some graphs. So for the graphs, you find like, okay, breadth first search. You will learn that what is the shortest path when the graph is not weighted. Then you will learn something else, probably another shortest path, single source shortest path, the Dijkstra algorithm. Okay, great. And then you'll go to some problem and you find that there can be negative edges. You find that negative edges, okay, so I need to learn something negative edges. Bellman-Ford probably, but negative edges. And so what I would recommend is not like read the whole, I don't know, CP algorithms or read the whole book, but try to solve some problems. And if you see that some problems are not solvable by your knowledge, probably you should look for something. You should read some more algorithms. And when you read more algorithms, you should solve the problems for this topic. Also the question, any suggestions for learning algorithms with self-study, how to overcome when you get stuck in learning or solving problems? You mean like when you get stuck on, so, you know, what I can tell about learning theory is not everything. So you need to somehow, so it's easy to learn things, then it's harder to come up with solutions for real problems. Real, I mean the problems of the competitions, not the real in life. But still, you don't like. I think I already partially answered to that question. So that learning, you learn until you know something, and you try to solve problems. And if it's tough enough, you go and learn again. But I think the solving is better. So you have to solve more and learn only when it's not enough for you to know something, to solve something. Anton asks, why would anyone prepare for a programming contest? I think I already answered, but if you're having fun, you can just solve problems. Yeah. If you want something to achieve, I don't know, get to some competition. I don't know. There are some competitions that you have to get better to get in. You have to prepare. I know it's not like preparing for a single competition. It's just you solving problems and you get better. For what I was talking about preparing is like not only competitions, I would say, like interview slash exam slash competition. So for example, if you want to get to a company, you would probably need to solve some algorithmic stuff. So if you go to FANG, they would most probably ask you to solve some of these kind of problems. If you want to go to I don't know, to your university, and there could be, so for example, JetBrains has JetBrains Youth competition. Probably it will give you some points in entering the university in their programs and getting grants. But I don't see any other reason so you have to prepare. But if you have one, you prepare. If you don't have one, well, you shouldn't. But like, I wouldn't say you have to prepare for a specific competition. Okay. Also a question about bootcamps. I don't know if there are bootcamps. I cannot recommend one. But sometimes in code forces they announce some of them, I think. So I can't say for that. Sorry. Let me continue. So how would I practice? How would I try to learn something new? So solving. So here on the right, a bunch of websites with problem archives and also the competitions on some of the websites. So first, I think it's to learn a topic, to learn one kind of problems, you need to try to solve it. So try to, for example, choose dynamic programming and solve some problems for dynamic programming. So what I would suggest, but it's not like the only option to do, I would sort the problem from easiest to hardest and try to solve them one by one, maybe skipping some of them if they're too easy. If it's too hard, I would go somewhere and learn for some theory or even to look up some solutions. Yeah, so this is the part when you try to learn some new topic. If you're not fluent like in this kind of problems, you should try to get better in it. The second one is, if you want to be better at competitions and in the limited amount of time, you could do some virtual contests. Well, the same as like virtual contests and online contests. So virtual contests are like online contests. So for example, in Code Forces, you could see that I don't know, there are some contests going on like each, I don't know, 3, 4, 5 days. And these online contests, you come up and some other 39,000 people also competing with you. And you have like 2 hours or 3 hours, or depending on what type of competition it is. And the time is limited, so you need to try to solve them under this time. And this is a little bit stressful, more stressful than when you're just solving with no time. But it helps you to concentrate on a small number of problems. And you need to think faster, you need to code faster, and you need to make less bugs. So without this kind of mock contests, you probably, so on your first contests, real contests that you do, most probably you won't do it without any flaws. So you have to do it. You have to try to do it to do it. So it's like, I don't know, mock interviews when you go somewhere. you want to enter your job or the university. The same is online contests as virtual contests, so that because online contests are not every time, you can try virtual contests. Just virtual contest is the contest that was before, but you can but you can run your own timer and solve these problems. What is the most important about these contests is that after you solve them, you are left with a bunch of problems you couldn't solve. And because you spent you spent much time thinking about them, but you still don't know how to solve them, learning how to solve them would make you a better. And so you need to learn how to solve them. You need to either think about them more, or if you don't know the solution still after thinking, I don't know, I wouldn't say the time frame you have to think in about them, but still you can read the solutions. So for most of the competitions, there are solutions posted. For example, in Codeforces, there are some posts with what the solutions are. You could read some discussions in the internet as well, so people can write some ideas how to solve them. And the most useful, what I find, is that you can read their codes. Reading codes of other people helps you not only to get how to solve this problem, but also how to implement, how to use the language. Because learning, I'm not talking here about how to learn the language and so on, but still, this helps very much on how to implement things, because you can implement it in different ways. And sometimes some ways are effective and some ways are not, in time, in memory, and in coding time. But well, reading codes, I think I learned to very much from reading other people's codes. So I just read code and I learn something new. So this is very important, I think, when you're practicing alone, because you don't talk to anybody, you just read something. But reading code is very important, in my opinion. So actually, what I'm talking here today is only my experience on what I did. Probably there are some other ways to practice, and I also stated them. So there are some camps, you can talk to someone, you can have a coach, and so on. So this is what I see for those people who want to do it themselves. Okay. So during the contest, so because the contest time is limited, and because you have to be effective during that time, you have to know how to behave during the contest. So one of the most important things I see is how you read the problem statements. So the problem descriptions has to be read and be understood. And because sometimes, well, let's see. So if I just open, I know, some problems. So this is from the last Codeforces contest. So what we need to do to read the problem statement. So you read that there is a square of positive area in the coordinate plane. Its sides parallel to the axis. This is very important. And what you're given is the coordinate of its corners. So there is a square, and you are given the points that are in the corners. But they're given in random order. So your task is to find area of the square. Okay, so this is a problem, but it's not enough to read just this. It's very important what's written in the input, in the output, and the most important what's done here, because you can read that, but still you cannot be very sure that you understood everything correctly. Depending on what's given in the input and what they expect you in the output, the problem can be very different. So here it's given some test cases. Each test case consists of 4 lines. Each line has a coordinate of a single point. Okay, so we have 3 test cases. Each test case is like 4 lines, and each of these 4 lines, they give you the coordinates of 1 square. And you need to print a single integer of the area. Okay, that's it. Great, so we know. So now we need to check if we understood it correctly. So let's take 1, 2, I don't know, 4, 5, 1, 5, 4, 2. We can even draw these points on a paper. We could see it's a square. We could see that it's actually the square of area of 9. After that, well, now after reading all these input and output examples, we can be sure that the problem is understood correctly. So we know how this output is generated from this input, and we know what the problem is about. In most of the, so is it the programming competition, or it's an interview, or it's I don't know, exam? You always have to know what they ask you, because if you understood it incorrectly, you will spend time on the problem they didn't give you, and this spends your time. It's not effective. You have to solve what they've given you. Okay. So you have to be very careful. You have to pay attention to the details, because details sometimes can be very they can contain hints. So for example, the input size, it can be a hint what complexity algorithm you have to use. If there is some specific thing they ask, for example, is the solution unique? I've included the example here. Probably you don't have to find a solution. Probably you just have to create a criteria to check that. So this is important things. Also, if they ask you, for example, I don't know, they instead of, so they are describing, so they're giving a graph you, I don't know, so they're cities, roads, they are describing you a graph, but they say that this graph is bipartite somehow. This is very important, because for these types of graphs, things are solvable easier. And for these types of graphs, probably they will hint you that you should use some special algorithms for these types of graphs. So reading problem statement is important. You have to find the hints as well in the problem statement. And these hints cannot be only in the legend section, but also in the input, output section, and in the notes, probably. Now, so after reading the problem statement, also, I forgot that not only reading the problem statement is important, you have to read all the problems during the contest, because you don't know which one is easiest for you. Even it can be hard, but even it can be difficult for everyone, but probably you know this problem, so you don't need to skip something from reading. And it shouldn't be that the contest has ended and you didn't read any problem in the contest, because reading all the problems does not take too much time if you're used to that. So I would suggest that in any contest, where the statements are open, you have to read all of the statements during the first half of the contest. Even if it is not the competition, that is a good, I think that's a good advice for an exam, for an interview, and so on. When they ask you something, you could read most of the things. You shouldn't skip that. But work on it or not, you need to decide. So you don't have to work on everything, but you still have to read everything so that you know what they've given you. What then? Then you should come up with a solution. So this is the hardest part, and this is the part you cannot learn. So you have to practice so that your brain learns how to do it. So I would give, I don't know, several tips on what would help you to probably come up with solutions. So what you generally should do, you should formalize the problem statement. So if they would be a story in a problem, it could be a story in the problem statement, you should formalize it, and you should state it in a mathematical terms, and that helps you to understand what the nature of the problem is, what the algorithms you can use for this type of mathematical objects. After you've formalized, you can first you can think of what it looks like, and if it doesn't help you, probably you could think the other way around. So you could think of, oh, could this be dynamic programming problem? Maybe I could do it, or maybe maximum flow. Okay. If there's still no idea, you could do something like, okay, so I cannot solve it for any graph, but can I solve it for a tree, for example? Or can I solve it for a chain graph? If I can solve this problem for a chain graph, you can create an algorithm for a chain graph, I don't know, in your brain, and then think about, is it generalized to trees? Is it generalized to general graphs? This can also help you to get the solution. But the main advice, I would say, if there is too much time spent already on thinking on what is the solution for the problem, you should try to skip it for now, read or try to solve next ones, and probably come back when you've done something, because it's very frustrating when you're trying to solve it for a long time, and every minute you try to solve it faster, but it doesn't help you to come up with a solution. So you just can skip it and get to the next problem, and in a calm way to think of the next one. And probably if you get some success from it, for example, you solve the next problem, you can come back to it. This is very important also, that as well as reading all the problems like in the first half of a contest, because your brain is human's brain is, I don't know, it's designed or just as it is, it thinks in the background. And even if you don't think actively about the problem, you could understand something that this problem, I don't know, is about string, I don't know, that string algorithm, or this is very similar to that one I've solved 3 years ago, something like that. And so reading all of the problems is important, and skipping the ones that you couldn't solve, try to get another success, so that it also gives boost to your brain, like hormones of you getting a success helps your brain to think of new solutions as well. So then after you come up with a solution, if it's successful, you write a code. So the writing a code is important thing here, because you need to write the code that works on all the test cases. So in a competition, in most of the competitions, your solution is accepted when it passes all the test cases that were generated by the judges, and they will contain the maximum test case, the smallest, all the side cases as well. So it has to work on all the cases. So before writing code, you need to think how you will implement it, because if it's the complex program, you most probably when you're coming up with a solution, you think in an abstract way. So I will read my graph, then I will run DFS, then I will run some dynamic programming, then I will do something, and then so on. But how you will store that graph, how you will store all the dynamic programming values, and how you will do all the transitions, you're not thinking about probably during coming up with a solution. So you have to, even if you have algorithmic ideas, you have to come up with the implementation details. So, and you have to come up it before writing code. So it's my advice, because writing a code that you already thought of is much faster than when you type it and think at the same time, because writing code takes your brain resources, and thinking about it also takes your brain resources. And for me, for example, it's better to think beforehand, to spend my brain beforehand thinking about that, and then implement it. So there are also some tips on how to write a program if it's complex. So try to make some, after each step, try to run your program so that it works. You can be sure that the bug is in which part of your program. You can try to break your program into different parts and use, for example, some part as a black box. I don't know if you have some data structure and complex solution that uses this data structure. Instead of a complex data structure, you could write something not very effective, but for sure working. And then if you write it and then write your solution and it works, you can be sure that the solution contains no bugs. And then you can write your data structure, the one that's effective one. And so you will most probably know where the bug is after you run the whole program. If the first part worked correctly, then after adding your new data structure, it starts working incorrectly. Probably your data structure is the reason. Yeah, so after you write a code, you have to test it. So you for sure need to test it on the examples given in the problem statement. You can change them a little bit and test on the new ones. You for sure need to test on the minimum test cases, because these are the extreme, like the cases that your program could fail. You could also, in some of your parts of the program, you can use assert directives to check if some conditions met, so that you see if it fails, you see where the problem happens. And the most important thing is that you have to read your code. So actually, you should not only write your code, but after writing, you should read it. In my experience, most of the bugs are found like reading the code. So if you read it, you must probably know where you. So most of the bugs are stupid, and like all that memes about the programmers taking that all this bug stupid and so on. So reading the code helps to find stupid bugs, and you have to read your code as well. And so after you've submitted, you probably got accepted, or the system told you that your program is not correct. For example, it returned your wrong answer, so that your program printed something incorrect, or it returned you something like runtime error, so that your program crashed. At this point, you could read your code, test your code on some cases, but probably those won't find the reason why it fails. You could use the thing called stress testing. So we need to somehow automate testing, because we don't know the test case that our solution fails in. We need to find it somehow. But finding it, we can use it like manually, create some test cases, calculate the answer for them. It would take too much time. But well, if you know some edge cases that you didn't include in testing before, you can try them. But if they don't find your flaws in your program, so when it fails, you could try stress testing. So for stress testing, you need to create another solution for your problem, which most probably works correctly, but it has to be another solution. So you don't have to copy some code from your main solution, because otherwise you could copy your bugs with it. You create another solution. So for example, if it's some kind of data structure problem, you can create a data structure just on the array that works for sure. so that you create, I don't know, instead of segment tree, you create an array and then do it just by loops in linear time instead of logarithmic time. And most probably it will work. And because it's written in another way, even if it doesn't work, your stress testing will find the difference between these two solutions, and you will find bug either in your first solution or in the second one. And you also need to create some program that will generate your tests, because you don't know which test it fails in. You should try on some random tests. And the goal is to find a small test case that makes two solutions give different answers. And so here is generators, how the generators are written. So I included some Python script, how you do it. You could do it in C++, you can do it in your language, in any language that is runnable, that you can run from console, from the terminal. You should create another solution, any language you want. And you could do some script, also any language you want. I've included some bash script here. I've just run 100 test cases, and if in any of the 100 test cases it fails, it prints some diff between output 1 and output 2, and in input there will be an input that fails your solution. And after you run this test SH, you will get input. You can debug it then, your solution or your main solution or your slow solution, if you're not sure if it's correct. So this helps you finding which test cases fail your solution very fast. But so it's not very fast to write those generators. So you need to write generator, you need to write another solution, you need to write script to do that. And even after running it, even after finding your tests, you need to somehow debug. So it's not very fast, but still it can be faster than just reading your code for 20 minutes trying to test on your test cases, because you can run a single test case, I don't know, in 30 seconds or in a minute, because you still need to somehow calculate what is the result of your test case. But here, you don't need to calculate. Your second solution will calculate, and your generator will just generate all the random test cases. And you find a small test case. If it's not small enough, you just decrease the size of test case. If it doesn't find that small test cases, so you found the minimum test case, probably, that it fails in some kind of minimum, and it will most probably help you to find your bug. So for debugging purposes, in my experience, I've used two types of debugging. So debug output is like on the right. So you just print it to error stream or output stream. This is a C++ example. Or you use debugger, whatever you want. I find debug output more convenient because it prints you all the information throughout the program, and debugger, you only meet it one by one while you debug. But whatever is useful for you. So I think it was the last slide. I don't know if that information was very useful, or you can comment on that. I think I will try to remember some of the questions you've asked, probably. Will I tell you about Pafos entering programming contest? Probably Alona will help me with that. What is that?
Yeah, I already answered in the comment section, but if you want to,
yeah, it's
something.
great. If it's answered already, you can just read in the chat above. Some hellos from my hometown. Hello. Okay, this I answered. C#. I know C# and JavaScript. Will that be useful for JetBrains contest, or should I also learn C++? Do we have any information on that, Alona? I don't know.
Yeah. You both
Also, you also
C and
answered. Okay,
JavaScript and also Python works for this purpose.
Mm-hmm. Yeah. You did work while I was just saying something here.
Something like that.
Do you know LeetCode? So yes, I know LeetCode, and I think LeetCode is very useful for you to learn how to program. So it doesn't contain, maybe it's even more useful for you to do this kind of contest. So I think it's more about how you understand algorithms, data structure, more of what kind of things you know than about coming up with the solutions. And I think lead code is very, very useful if you're not into solving puzzles, but if you are into getting interview done, or if you are into getting to university, lead code is a thing. But if you are high school students and you're like aiming for a computer science program, probably you will learn all that things in computer science program, and a good computer science program will have the practice on that type of problems as well. So it's probably how can I
We have some.
okay, so questions. Don't you think that reader after colors don't affect too much on your knowledge? Maybe I'll better try to solve and drop them if you can. So depends. If you are experienced one, probably try to solve it more and more is better. If you are learning, I think like if you're learning things, not learning how to come up with solutions, sometimes it affects it. So it depends on what you're aiming. So if you're aiming to learn how to do it, you should probably read. If you're aiming to train your brain, but I also think it can be different for different people, because some people are smart and some people are not that smart like me. So mostly I learn not from my things, but I learn from other people's works. And that helps me to understand. So after analyzing what it is, it helps me to understand how they thought to come up with it. Probably that's it. I cannot answer for sure if it is. What do you think about, I don't know how to pronounce EDABIT, so I don't know what it is, so I cannot comment on that. Also, there was a question: how can I master dynamic programming problems with multiple parameters? Let's say more than 2 variables, 2D, 3D. Well, I would recommend to read examples of the solutions. So, how I learned dynamic programming, I tried to read how these solutions work. So, what are behind them, and then I understood how any problem is solvable with dynamic programming. And like the experience, like the advanced problems that dynamic programming, they don't include then like the skill of how to solve it using dynamic programming, but about optimization. So actually, like mastering dynamic programming is not easy, because you have to see many problems and many solutions and maybe solve and maybe like come up with them. But like you can, when you do it, you most probably will solve any problem, but it will depend only on how effective it does. But I don't have some kind of easy solution for that. So you have to get problem, you have to try to solve it, you have to read the solution. The same thing for dynamic programming, it works the most, but it worked for me the most. So that yeah. Any more questions?
It looks like our time is almost up. So if you have any more questions, don't hesitate to join our chats in WhatsApp and Telegram. And you can find someone who is preparing for the same contests as you, and maybe it will be helpful for you. And we have, I guess, the last question. Can you answer it?
Yeah. So I think learning at that point of rating, I think it doesn't depend on what you learn. It just depends on how you come up with solutions. So as like Artyom asked above, you have to learn how to come up with solutions. So it's just solving, and probably, well, I also don't know how you go, but like practicing takes you. Probably you need to also try to talk to people with who already achieved that kind of expertise, like the ratings 3000 and more, and how they think about problems could be very interesting, so that it helps you to also think in these ways. Because like reading a solution is one thing, but coming up to it is another thing, and you probably need to analyze how they came up to it, but not what it is. I hope so. Talking to people that expertise and try to solve problems. Maybe not reading like problem analysis from just after you've thought about 5 minutes would be a good advice, as Artyom said above. Yeah. Well, I wasn't at high ratings, so 2800 I think is my also the highest one. So I'm not the one that did very good, and probably because I didn't do too much thinking about those and reading editorials as well. I don't know. Programming language recommending to use, depending on what your goals are. If you want to, I don't know, is Alihan, if you want to go to 2800 rating, I would certainly recommend C++. If you only want to get to university, you want to get to the interviews, go to company, or you go to practice, or you like IT, I think it is like whatever you like. So Java, Kotlin, Python, C#, whatever is okay. And in general, in life, you use an instrument that is required for that kind of problem. So if you do, I don't know, if you do web, you would probably, if you do front end, you would probably use JavaScript, or maybe nowadays you will also use some other lower level languages as well. So why not Kotlin? For sure, I would recommend Kotlin. I use it at my work, but it's not that you have to use one language at your life. You have to learn different languages also to see the differences, also to see what are they useful for. Probably some of them can be useful for everything, but in different ways. What book would you recommend to read about algorithms? Oh, nowadays I'm pretty old. Probably I don't know any new books about algorithms, so I would see LRS, Corman, Laserson, Rivest, and Stein. There are some of them. I didn't read much books about algorithms, I think. So I can't say anything better than that. I think there are better. Because this is pretty old one already. Too much time passed.
Yeah, I can also add that to the subscribers to our program's newsletter on our websites, you can get a free special collection of useful links that we selected specifically for applicants like yourself, and you will find some tips about algorithm there as well.
C++ book for junior. Can't say. I would try to do some online course, probably with like step by step. I don't know even for C++. I've done the Russian language course, so I cannot recommend that for everyone. So Sorry for that. I don't know anything about C++. How to learn it, the book for junior. So I know there are like, I don't know, Bjarne Straustrup book, but still it's not for junior.
Okay, it looks like that's it for today. Thank you very much for participating. That was really interesting. So
yeah, that was epic.
Good luck. Yeah. Good luck with your preparation, and don't hesitate to ask us questions in the chats. And bye bye.